Hi children, hope everyone is fine at home, isn't it? Okay, let us today start our physics class. And let me take you to the world of physics. You know, physics is useful in our daily life, isn't it? So already in the class, we have studied different type of forces. So this year, we are going to study forces acting on fluids. What are the different forces which is acting on fluids? We have studied about the buoyant force acting on fluids, isn't it? Principle relating to the buoyant force, the body, whether it can, which will be floating, some of the body which is sinking, all that we have studied through this lesson. So, now we are going to the other principles relating to the force on fluids. So, already we have studied, children, buoyant force acting on fluids. That is, an upward force is acting when it is immersed fully or partially in a fluid or a liquid. That is what we have studied. Next, let us go to a law which is called as Pascal's law. Today, we are going to study about certain devices in which you apply pressure. So, already about pressure, we have studied in standard 8, isn't it, children? Yes, I think you remember. Yes. So, one of the commonly used thing in our surroundings, that is in our environment, you can see a device which is called excavator. Excavator. I think all of you know that. Excavator. Did you see that thing? Usually we say JCB, some of you say like that, isn't it? So what is the use of that, children? What is the use of this excavator? It helps in environmental protection and disaster management. I think all of you know that, isn't it? Helps in environmental protection and disaster management. What do you mean by that? Suppose there is any natural disasters, buildings may collapse, isn't it? What will happen? You can see this excavator helps to remove the remains which is present there, houses, buildings, etc. Or otherwise this is called as earth mover. Yes? So all of you know that it is otherwise called as earth mover. Now you know how it is working. All of you have observed it, isn't it? I think all of you would have observed it, how it is working. Which is the main part here? In this, which is the main part? It usually consists of a lever, isn't it? Usually consists of a lever here. You can see the driver will be pushing a lever. So when you push the lever, automatically what will happen? You can see a system, that is mechanical arms will be surrounding that. This arms will start to move. Only just to move that lever, what will happen? Mechanical arms will begin to move. Any side it can be moved with the help of the pressure applied on what? This lever. So what is the principle behind it? Why it is working like this? That is what we are going to study next. Okay? How it is coming, how is the pressure applied? What happens when the pressure is applied? All that we are going to study now. So for this, let me introduce some small experiment which you can do at home, isn't it? All of you have toothpaste, isn't it? Yes. That is toothpaste which is completely finished. Empty toothpaste. Yes. Now make small holes in this toothpaste. I think I can draw a small, like this. Completely empty toothpaste. Then what you have to do, make small holes on that. If you make small holes on that, what will happen? And fully fill it with water. First fill it with water, then make small holes in that, then apply a small pressure on that. Just press it. So if you press it, what will happen? You can see water will be going out through all these holes. This you can do at home, children. Very simple experiment, isn't it? So water will be moving, or it will be moving away, that is throughout these holes. Similarly, if you have a toothpaste which is fully filled, fully it is not empty, fully. What will you do? If you want to remove the paste, what will you do here? You have only a small opening here. So what will you do? Just give a small force here. When you give a small force here, what will happen to the paste? You can see it is coming out like this. So you can go do at home. So what will happen here? If you apply a small force, what will happen? The paste will be moving out. Isn't it? So what are you doing here? Applying a small pressure. Applying a small pressure. So when you apply a small pressure, what will happen? It is completely transmitted throughout this, what is present. If it is a paste, means fully that liquid, it is fully present. It is transmitted throughout that paste. So when it is transmitted throughout that place, this pressure equally on all sides. The pressure only one side you apply, but what happened? The paste will be coming out. Like that if you do here also. Isn't it? Applying pressure on one side, what will happen? Equally you can see water will be what? Coming out. Isn't it? Like this ball, fully ball you are filling with water, ball fully filling with water, then make small holes on. After that give a small press. If you don't have ball, you can use a polythene bag also. Then fully fill it with water. Then what you have to do? Give a small press there. If you give a small press, what will happen? Water will be sprouting out. All the direction equal. Smaller classes, I think you would have done all this. Isn't it? So what can you understand from this? What can you understand? If you apply pressure on one side or any part, what happens? Equally that pressure will be transmitted to other parts. And what happened? Water will be coming out. Equally on all the directions. Understood? So this was found out by a scientist by name Blaise Pascal. Blaise Pascal. And this whole thing will be taking place in a closed system, that you have to see that. Closed system only all this will be taking place. Suppose you have water like this, isn't it? Water which is present here. If you apply a small force here or a pressure, what happens? Water will be coming out or water will be changing the level. Isn't it? So usually you have to see in all these experiments in a closed system. Pressure applied in a closed system. If you apply pressure in a closed system, what will happen? Equally it will be transmitted throughout that. Understood? And this law was found out by whom? Blaise Pascal. Understood? And this law is called as what? Pascal's law. This law is called as what? Pascal's law. Okay, I think all of you understood what is this Pascal's law. If you apply pressure at one point, anywhere, in a closed system, what will happen? Closed system, what will happen? Equally it will get transmitted to other part. Understood? So as a result, what will happen? Whatever effect is there, it will be easily taking place. So this law was found out by whom? Blaise Pascal. So this law is called as what? Pascal's law. Now my next question. Will the volume change when you apply pressure? For this, what you are doing is take a small syringe. All of you know what is a syringe, isn't it? Yes. Fully fill it with water and close the opening. That opening you have to close it. Then fully press it. Will the water go out? No. Is the volume changing? No. So when you apply pressure, volume does not changes. This also were given by whom? This also were given by Pascal. Understood? So I think all these points, did you understand now? Here we have deal with Pascal's law, then how it is taking place, all that. Now we are going to study about the example using this Pascal's law or this principle. What is the principle? If you apply pressure at one point, equally it will be transmitted to other point also in a closed system. Understood? So first one is hydraulic brake, second one is hydraulic jack, and third one is hydraulic press. I think these terms from this hydraulic, something related to the liquid, isn't it? Something related to liquid. Everything is working based on that liquid. So what is meant by this hydraulic brake? That is, what is hydraulic brake? Come on, just think for 1 minute, children. Easily you will be getting. Arrangement of braking mechanism. Okay, used in vehicles. All the vehicles you know. Arrangement of braking mechanism used in vehicles. Understood? By using a fluid. By using a fluid, what happens? The controlling mechanism is converted into braking mechanism. That is called hydraulic brake. Understood? Arrangement of braking mechanism. We are using a fluid, brake fluid. When you use this fluid, what will happen? The controlling mechanism, what happens? It is getting converted into braking mechanism by using this principle. That is called as hydraulic brake. Next one is hydraulic jack. What is hydraulic jack here? It is a lifting mechanism. You would have seen in a vehicle, car wash, etc. Isn't it? Where car will be lifted. Yes, car will be lifted to a certain height by using this device, which is called as what? Hydraulic jack. So what can you say from here is mechanism used for lifting certain objects, especially in the car wash, etc. You would have seen lifting a car such that easily we can clean that car, etc. Lifting to a certain height. So there we are using the device which is called hydraulic jack. Okay, next one, hydraulic press. Yes, what is meant by hydraulic press? It is also another mechanism in which we can press it, apply a compressive force by using a certain cylinder. Understood? So what happens? Easily it will be compressed. That is called as hydraulic press. So all these cases, what happens? All these cases, what happens? We are using which principle? Which principle is used here? Yes, we are using the principle of, that is, which was found out by Pascal. Okay, so now we are going to study how is this hydraulic jack is working. Very simple working only. How does it work? Understood? How does an hydraulic jack work? Already I told you what is a hydraulic jack. It is used for lifting what? Heavy loads. Heavy loads. Now how these loads are lifted? That is what we are going to study. For this we are taking two cylinders. Let me explain. Like this, it is connected by means of a wire. Both are of same, two cylinders are taken like this. And these both cylinders are connected by means of a wire like this. Wire easily it is connected, small wire. Fully it is filled with water. And we have a small piston like this. You can see the area of cross section of both is same. Okay, now what we are going to do here is apply force here. Imagine that we are applying a force of 1 Newton. 1 Newton force is applied. What will happen when you apply a force here? Piston like this. Apply a force here. 1 Newton. This also you are applying the same 1 Newton force. What happens here? You can see that. Will the level be changed? No. There will be no change in the level. Because the force which you apply on both will be the same. 1 Newton force. Let us consider as 1 Newton. So the force applied on both will be the same. So what will happen here? There will be no change. Understood? Now another case we can take is, another case. Increase the area of cross section. Increase the area of cross section here. We are increasing the area of cross section. Yes. So what is the difference you can see here, children? What is the difference you can see here? That is, we are applying a certain force. Okay, let the force applied here be F1. What is the area of this tube? Let us consider it as A1. Yes, here the force applied, let it be F2. What is the area here? A2. Let it be like this. So according to Pascal's law, what you have studied, we are applying a certain force here. 1 Newton force you applied here. Can you apply the same amount of force here? That is the question now. Can you apply the same amount of force? Because this area of cross section is what? Little bigger, is more, isn't it? So can you apply the same amount of force, that is 1 Newton force here? That is the question. So for this what you have to do is, if you apply a certain pressure, according to Pascal's law we have studied, let the pressure here be P1 and the pressure be P2, isn't it? So P1 is equal to P2. According, that is, if you apply pressure in one cylinder, what will happen? Equally it will be transmitted to the other cylinder, isn't it? So you know that P1 is equal to P2. Pressure applied at one point, what happened? Equally it will be transmitted to the other point. Yes? Okay. Or in the 8th standard, something about pressure did you study? Yes. So what is the formula for pressure? Already you have studied 8th standard. I think you recollect it. I'll give you 1 minute time to recollect. Okay. Yes. Got the answer? Yes. P is equal to F by A. P is equal to F by A. What is this F? Force or thrust acting. Last year you studied. Thrust divided by A. Its area. Isn't it? So here we are considering two force. Here one force, another this side also force. So what can you write? P1, what can you write here? F1 by A1 is equal to F2 by A2. Did you understand, children? P1. P is equal to F by A. So what will be P1 is equal to? P1 will be equal to F1 by A1. And what will be P2 is equal to F2 by A2. Okay, now we have to find F2. So how will you do it? F1 into A2 is equal to F2 into A1. So what will be F2 is equal to? F2 is equal to F1 into A2 by A1. This is the thing. Formula to calculate F2. We are going to calculate what will be the force applied here. That is why I have done all this. Understood? We are going to calculate what is the force applied. And if you apply 1 Newton force here, what should be the force applied here? That is why we have done all these steps. I think clear for you. Isn't it? So F1 into A2 by A1 is equal to what? Is equal to F2. If the area of cross section of the second piston is 100 times, we can write that. If the area of cross section of second piston is 100 times more than first piston. What can we write, children? I think you have understood. If the area of cross section of the second piston is 100 times more than that of the first piston, then what will you write? What can you write here? 100 times more. You can write is equal to 100 A1, more than the area of cross section of the second piston. Understood? So, what will you write in the next step? Next step we can write A2 by A1 is equal to 100. Okay. So, next what, instead of A2 by A1, what you have to write here? A2 by A1 F into, instead of A2 by A1, what will you write here? 100. F1 into 100 is equal to F2. So, what can you understand from this? F2 will be 100 times more than that of F1. From this, what can you understand? F2 will be 100 times more than that of F1. Clear, children? So, what will be the force applied? What should be the force applied here? What should be the force applied here, children? 100 Newton. Understood? Compared to this, it should be 100. That is, if you apply 1 Newton here, if the area of cross section is more, how much force you have to apply here? That is why we have done all these steps. All these steps we have done here. Understood? So, how much is the force applied here? It will be 100 Newton. So, this is how if you keep a loaded vehicle or any vehicle here, at the top of this much force you apply, only then what will happen? It will be able to lift it. Okay. So, this is how a hydraulic jack works. I think all of you it is clear. Yes.